Hello everybody, I'm Akerke from Accessibility Club, and today we're going to cover the topic from IB chemistry course called energetics. We'll cover only the cell part now, and the HL part will be explained in the next video. Let's start. The essential idea of this unit is that enthalpy changes from chemical reactions can be calculated from their effect on the temperature of their surroundings. You need to clearly understand the difference between system and surroundings and their effect on each other. It is also very important to keep remembering the first law of thermodynamics, namely that energy cannot be created nor destroyed, but it can be transformed from one form to another. So basically, the chemical energy is transformed to heat energy. That concept will be followed in all topics in this unit. Also, you need to clearly distinguish two terms, heat and temperature. Heat is a form of energy, and the temperature is a measure of the average kinetic energy of the particles. Basically, heat is energy, the form of energy, and temperature is a measure of that energy. Here you can see that energy transfer can be done through convection, means like the transfer of heat between two bodies by currents of moving gas or fluid. Then conduction is from solid to solid, and radiation. Total energy is conserved in chemical reactions, and chemical reactions that involve transfer of heat between the systems and surroundings are described as endothermic or exothermic. During exothermic reaction, heat is released by the system to the surroundings, so the surroundings gets warmer. And as an example, we can consider the combustion of methane. All the combustion reactions are exothermic since they release heat energy. The enthalpy change is always negative in combustion reactions, so this means that the products have more stable bonds than the reactants. So the products have less enthalpy than the reactants. That's why they are more stable. And that is why the enthalpy change is always negative. To determine the whether reaction is exothermic or endothermic, we need to look at the sign of enthalpy change. So now we know that if the enthalpy change sign is negative, then it is an exothermic reaction. During an endothermic reaction, heat is absorbed from the surroundings, so the surroundings gets cooler. For example, melting. It is a reaction change of state, and the enthalpy change here is positive, which means then that the reactants have more stable bonds than the products. Basically, reactions that release heat are exothermic, and the reactions that absorb heat are endothermic. So to determine which reaction is endothermic, we need to look at the sign and the sign of the enthalpy change. If it is a positive, then reaction is endothermic and it absorbs heat. Now let's consider the calculation of heat change or the enthalpy change when the temperature of a pure substance is changed using this formula. Q equals m multiplied by C by delta T. Q stands for amount of heat, m is mass of the substance, C is a heat capacity, and delta T is change in temperature. To get the enthalpy change, we need to use this equation, delta H equals minus Q divided by N. Q is the heat released in kilojoules, and N is number of moles of a substance that has been combusted. So let's consider the working example. We have some experimental data from which we can get the enthalpy change of combustion of ethanol. We have our formula Q equals m multiplied by C by delta T. We know the m, the mass of water, is 150 grams. Multiplied by heat capacity of water, it is a constant, 4.18 joules per Celsius. And we need to know the delta T, so the change in temperature. We need to subtract the maximum temperature from the initial. So we multiply all these values to get the amount of heat in joules. The enthalpy change is measured in kilojoules per mole, so we need to convert our joules to kilojoules, as we know that 1 kilojoule is 1000 joules. This amount of heat is supplied by mass of ethanol burned, so we need to subtract the final mass of spirit burner from initial mass. so that we can get the mass of ethanol burned. To determine the amount of ethanol moles reacted, we need to use this formula. Number of moles equals mass divided by molar mass. So the molar mass of ethanol equals 46.08 gram per mole. So we can do these calculations to get the number of moles reacted. So we use the next formula, which is delta H equals minus Q divided by number of moles. Use the amount of heat released, which is 16.4 kilojoules, divided by number of moles of ethanol reacted, and we get that value. So the enthalpy change here is minus 721 kilojoules per mole. That the value of enthalpy change is negative because it is a combustion reaction and it is exothermic. Then there are two terms which definitions you must remember, since your exam may require the explanation of these terms, and you must use correct terminology to get a high mark. So, first one, enthalpy of combustion is defined as energy change when 1 mole of a substance is burned in excess oxygen. Second is enthalpy of formation. It is defined as enthalpy change when 1 mole of a compound is produced from its elements under standard conditions. Enthalpies of formation are determined using the Hess law, and Hess law states that the total enthalpy change for a reaction is independent of the route taken. It is a special case of the law of conservation of energy, or, as I said before, the first law of thermodynamics. Get the values of enthalpy of reaction using the enthalpies of formation, we need to subtract the total enthalpy of formation of reactants from total enthalpy of formation of products. In enthalpies of combustion, to get the enthalpy of reactions, we need to do the opposite thing. We need to subtract the enthalpies of products from the reactants. The next thing you need to know is bond enthalpy. So it is basically the energy of bond between atoms. So the greater the value, the stronger the bond. How to calculate the enthalpy of reaction using bond enthalpies? It is the same as with enthalpy of combustion, but here there should be different values because bond enthalpy values can be found in section 11 of the data booklet. You can find it here. But the important thing to remember that those represent mean bond enthalpy values, which means that it is just an average. They are approximate and might not correspond to the real value, but still can be used to calculate the overall enthalpy changes. So the bond enthalpies and the enthalpies of combustion and formation could differ because in calculations of bond enthalpies, the averaged values are used. The process of bond breaking is an endothermic process, since the energy is needed to separate the atoms in a bond, and the process of bond making is exothermic, as the energy is released when atoms are bonded together. So that's all for the SL part of the unit energetics. If you have any questions regarding IB chemistry or biology material, you can always contact me and write to my email. Thank you for watching.